हेलो एवरीबॉडी। हमारा आज का सवाल है नंबर ऑफ प्रोविंस। सो वी हैव गिवन n cities. Some of them are connected while some of them are not connected. If a city A is connected directly with a city B and a city B is connected to city C, then A is connected to indirectly with a city C. Means if we have a node A, we have a node B, and we have a node C. And if node A is connected to node B and node B is connected to node C, then we can say node A is indirectly through this path. First it go to the B, then it go to the C, connected to the C node. So we have also given a province is a group of directly or indirectly connected city and no other city outside this group. Means this group is called This this group is called province if all the cities are directly or indirectly connected with each node. So I'm sorry, it is indirect graph. Means we can go to the travel to the both direction. So this is the province. So we have given the n cross n matrix is connected where if the value is 1 means there is a path between node A and node B, and if value is 0 means there are no path between node A and node B. Let's see in this example. We have given an array 110, comma, next 110 and 001. So for this, like we have given node 1, 2 and 3. Arrays 1, 1, 0, 1, 1, 0, 0, 0 and 1. So it is showing that node 1 is connected to itself, means index 0 value, index 0 means node 1, and it is also connected to node 2 because value is 1, but not connected to node 3. Here you can see in this example, this is node 1 connected to node 2 but not connected to node 3. A node is also connected with himself, means we can go one from the one directly. Node 2 is connected to node 1. You can see here node 2 is connected to node 1. Node 2 is connected to itself and no connection between 2 and 3. 3 is only connected to itself. So we have to find how many provinces are there. So in this example you can see there is a one province is there and one province is there. So all the node within these province are directly or indirectly connected to each other. But you can see 1 2 connected to each other, but 3 is not connected to each other. It is single node, so it is alone a province. In this example you can see every node is connected to himself only, so there are 3 nodes, 3 province. So it is similar to the connected components, means if there are a node A and a node B, node C, and there is a path between these nodes, then this is all are connected component. There are one connected component. We can go from A node to B node, we can go from A node to C node, we can go from C node to B node by A node. So these are all connected component. But if there is not a direct connection between node A and node C, then you can see there are two connected components. Mean one connected component is this and second connected component is this. So we have to find the connect number of connected component in this graph. So this is our problem. So how we will solve this problem? We will solve this problem by DFS or BFS. We can solve this problem by both methods. So let's solve this problem. So we have given a graph 1 and 2 and 3. 1 is connected to 2. So what we will do? We will create a visited array for each value. Means for each node we create a visited initially. All values are false. All values are false. Then we will make a DFS call and pass the values. Means when if we are at one node, its neighbor is 2. So by DFS call, we can go to the 2 and mark it visited. Means first we mark it visited, then make a DFS call, then go to the node 2 and we will mark it visited. At node 2, how many neighbor it has? It has only one neighbor, this neighbor. But this is already visited. So there you can see there is a direct path between these nodes. So for this node value is true and value becomes true and our correct connected component currently 0. But there for each every DFS call means the DFS call we will make from our main. For every DFS call the count will be increases to 1. So what we will do to find uh, this is our node. So to find the connected component, we will set connected component to 0. We will create a visited. We will create a visited matrix, Boolean matrix. Initially, value will be false. Then after that, we will update the value to true as soon as we visited the node. So what we will do? We will make a for loop. Means we will make a for loop from I equal to 1 to n. N is the number of nodes. Means there are 3. So we will iterate a loop 3. Then we go to this node. If this node is not visited, means if visited of our current node, means our current node is I, then we will make a DFS call. In DFS call, we will pass our graph and we will pass our visited and we will pass our current value. We will pass our current value means at which node we want to make the DFS call. This is our main body DFS call. So how DFS call will look like? So you can see first in the DFS call, we will make the element visited true. Means in DFS, what we will do? We will make visited of current, our current value equal to true means we will make its value true means we will mark it visited. Then what we will do? We will find its neighbor. We will find its all neighbor. We will find neighbor. We will find its neighbor. And if how we will find its neighbor? So we will make a loop means we will make a loop for I to at current index means is component means graph node current node I index means current node I index equal to 1 means there is a edge between those two nodes and our next node means our I node is not visited. If it is not visited, then we will make a DFS call for these node. So let's understand how it will DFS call will work like. First in the main menu, all the values are false. all the values are false, we go to the node 1, then we make a DFS call. Initially all the values are false, when it's visited is marked to true. It's visited is marked true. Now then it has only one neighbor, it has neighbor 2. So we will make a DFS call for node 2. We make a DFS call for node 2, we will mark it true. 2 has only one neighbor 1, but it is already visited, so we will not visit it again. Then there are no call, then we will return to the one node itself. Then after that we will return from this. Then we will check for value 2. 2 is visited, so we will not visit it. Then our current component is increased to 1, means current component is increased to 1 for this component province. Then we check for node 3. 3 is not visited, so we will make a DFS call for this value as well. Then our current component, current province is increases to 1, then our current province is 2. So this is our working of the code. So if we run in this example, initially our visited are false, so we will start from this. It will mark true, then it does not have any neighbor. Then we go to this, we will mark true. Does not have any neighbor, we go to this mark true. And for each DFS call from main menu, our count will increases by 1. Then it is 3 different province, so we will return 3. So how the code is working? Let's check the code. So this is our let me zoom. This is our find circle num. This is our main function. So we have given a two-dimensional isConnected array. So first we will get the size of the array. Then we create a visitor matrix as we talked before. So we will create a visitor matrix for the same node as in the graph. Initially we set the count, means our answer value to the 0. Then we iterate a loop from I equal to 0 to n. For making a DFS call, means the component can be different. It is not necessary. It is not necessary that all components of the graph are connected. Means like this can be the graph also. This can be a graph. It has two components that are not connected. So this can also be the case. Then we will iterate a loop from 0 to nodes. If our current node is not visited, for every node current node is not visited, then we will make a default call for this and increase the count value by 1, means increase one value. Means there are a starting point, like if we see, like we have given this value, we will, like we start from our DFS call from this. So in the DFS call we will traverse this node also, this node also. So there will be only one call for this component. Then we go to this node, and second DFS call we will traverse this node and this node as well. So there is only two calls, DFS calls. So we will increase the count value for 1 for every DFS call from the main menu. Then we will check the DFS function. We are taking isConnected, means our graph, our boolean visited array, and current value and vr. Initially we will set its node and mark it visited. Then we will iterate and find its neighbor, means if isConnected current of I, means we will iterate I in the length and check if current of I equal to 1, means it means that there is a direct path between two nodes and nodes is not visited, then we will make a DFS call for this node. This is our solution if we run it. So very nice solution. Similarly, like we have given this answer, we can also solve this problem using BFS. Process is same. In DFS, we go to the every in DFS we go to the every deep level, means in DFS we go to the deeper level. But in BFS, what we will do, when we are at node, we will find its all neighbor. We will find its all neighbor and process on this neighbor and mark it with step. Like we have given like 1, 2, 3, 4, 5, 6, 7, 8. So in DFS call, the call is made from this, then it will return value, then call made from the here, then flow go here, it will return value, then flow go here. So this is our DFS call. We go to the depth, then we will solve the problem. But in DFS call, first we mark it visited, means we will mark it visited. Then in our queue, we will add its all children, means all direct neighbors. We will add 2, we will add 3, then we will process 2, 2 is processed, then 3 is processed, then we will add all its children into the node. So we will add all its children into the node. Then similarly this will be the solve. So we can solve this problem by BFS also, but I think this is a good approach. So what is the time complexity? What is the time complexity? So here you can see we are iterating a loop for all the nodes. So we are making a call for n, and in our DFS call, we are we are again iterating to the all the nodes. Means our time complexity is big O of n square. Space complexity big O of n for our visited array. So this is our space complexity. So this is our solution. Thank you.